Good afternoon, everybody. So, thanks for the introduction. So, as stated, I'm going to talk about interoperability for clouds. So, I'm sure and talk about what CCICI, which stands for the Cloud Computing Innovation Conference of India, what we are doing in that space. So, this is definitely open space for innovation. I'll go over what we have done. We'll have a recorded demo, and if anybody feels like participating in this and helping chart a strategy for India for cloud computing, please give me your names, and I'll be more than happy to sign you up. So, cloud computing has a lot of publicity nowadays, and here are some cartoons. Which shows you how much cloud is there in today's world. The first one is a student. So you got both of these, a student cartoon. The first one, the student has given the answer cloud for everything in the question paper, because he says, my dad says cloud is the answer to everything. And the second one, you've got platform as a service, you've got software as a service. You may not have heard of homework as a service. Okay, so that is the second one. Let me first go over why hybrid clouds, why federated and interoperable clouds are important. So first of all, if you look at modern day cloud computing, then this has definitely changed things a lot. Nowadays, for example, there are many startups which are only on the cloud, and many, definitely among enterprise also, there's a tendency to move towards cloud computing. If you ask me what are the things, the major reason is, first of all, agility. That is, if you look in the earlier days, you had to go and you had to get a physical server, put it in, make electrical, those kind of connections. And in the cloud computing, if you want to increase the amount of infrastructure resources devoted to an application, say for example in Amazon, it takes on the order of 30, 40 seconds to set up a new virtual machine. Then of course the scalability aspect is also there. That has enabled new applications, including big data. So there are many companies which are doing big data applications on the cloud, and they may not need the big data. Of course, requires huge amount of computing capacity. That may not be needed all the time. What the enterprise can do, the enterprise can sort of rent the hardware needed, the resources needed for a cloud provider for a short period of time, and then use it. And then, of course, it's also very useful if the enterprise wants to experiment with a new application. That can be done on the cloud without incurring a lot of fixed cost. Finally, there's the financial flexibility. You can either own your own infrastructure, which is the traditional model of capital expenditure, or you can rent it, which is the cloud model. So then that's it. Because of all of these advantages, particularly if you look at the ones with regard to agility and scalability and the ability to experiment with new things, so organizations that leverage cloud computing are definitely going to be more effective than enterprises that do not, because they'll be able to adapt to the changing needs of the marketplace much faster. So if you take in India in particular, government is fueling the adoption of cloud, and I think this is a very good thing, because instead of saying, okay, we are a poor country, we don't need cloud, we've come to the opposite example, the opposite thing, that in order to effectively do government services to huge numbers of people, population of India is 1 billion or something, I think. What governments have realized is, in order to provide all these services like Aadhaar, in order to make property tax easy and transparent, in order to make effectively collect things like sales tax and so on, everything is being computerized. And that of course implies, because India is on such a scale, we are not a small country, we are a huge country. And the only way to do this is through some sort of cloud computing. And of course, some of the major initiatives are shown. Aadhaar is one major initiative, which already has saved the government a lot of money. Though of course, I think Professor Gopinath here is going to talk about some of his concerns on that. But definitely, it has saved a lot of money and helped a lot in linking government records together and helping the government enforce things. There is Meghraj, which is a sort of government cloud of clouds. So you may have different governments which will all have their own cloud or different departments, and how do all of these work together? So that is an initiative called Meghraj, which was done by DST. And in digital India, there are many useful things, like for example, the ability to store documents digitally in the cloud, so that if you go to a bank for a loan, you don't have to search in your house to find 50 documents. They're all on the cloud, and you can then, use the cloud service, give temporary access to the document to the bank, and they can examine it, and so on. And obviously, the digital documents will be a lot more secure than than paper documents. And this is reflected in the number of startups on the cloud. So this is a slightly older slide. It shows that there are 395 cloud startups purely focused on the cloud in Bangalore itself. And of course, you take the whole of India, that's a larger number. And this is a couple of years old. So today, there's even more. So you can see that a lot of people who have seen a lot of opportunity in the cloud and who are moving in that direction. So first of all, so now let me talk about why. So we talked about cloud computing and why that is so important. Why is interoperability in cloud computing important? So there are a number of reasons. First of all, one reason is to avoid vendor lock-in. Suppose you start with a particular cloud provider and your enterprise is working only with that cloud provider, whoever it is, and then the other cloud providers have completely different APIs and the other cloud providers have completely different facilities, then you're locked into that particular vendor. And so you're sort of at the mercy of that vendor, and the vendor can increase prices as they want, and so on and so forth. So this problem is very key. If you take NIST, which is the National Institute of Standards and Technology in the US, they said interoperability is a key requirement for the US government cloud. And so now many people think that, okay, vendor lock-in is good for the customer, for the enterprises, that is cloud users, but it's not good for vendors. But I think the contrary view, which says that interoperability is useful even for vendors, because as long as there is vendor lock-in, many enterprises will hesitate to go towards the cloud, because they say, well, suppose they put everything in the cloud and then it's locked in, then what do I do? What will happen if clouds are interoperable is that more people will be willing to go to the cloud, because they say that, well, if I don't like this vendor, I'll go to some other vendor. So my view is that the vendor lock-in, the interoperability will be better for the vendors, in addition to being better for cloud customers. Now the second question is, why interoperability? Why is interoperability important? This is just a question of reducing cost and reducing vendor lock-in and those kind of things. So answer to that, I would say, is no. So basically, if you look at, let's take a historical example of the internet. Okay, so in the beginning, there was no network. Each company or something had its own network, which was completely proprietary. Then after that, what happened is that the IETF, they defined standards and defined the internet. Okay, so initially we had first generation, there was a whole host of applications such as email and so on, which relied only on networking. Then once you had more powerful things like browsers and so on, then immediately what happened is that all of us know the World Wide Web came about. If you look at the internet today, people really don't distinguish between the internet and the World Wide Web. We can have all sorts of cross applications. We have very sophisticated applications like Facebook and those kind of things, which were, if somebody in 1960s when the internet, or 1970s when the internet just started off, if somebody had talked about, well, one day we may have a Facebook, or so one day we may have Twitter, or something like that, people could just not have imagined such things. But what really made all of this possible is the interoperable networking infrastructure. When the interoperable networking infrastructure came, in fact, cloud computing itself is a perfect example of how networking has enabled some applications people could never have dreamt of. So the thing is, but somebody who was there at the beginning of the internet could never envision the kind of things that would happen in the next 20, 30 years. The same thing with cloud interoperability. Today we are starting with cloud interoperability, and I'm confident that if we achieve the infrastructure we need, in 20, 30 years, there could be a huge applications which you cannot even dream of today. So one example I've given over here, which is kind of a little bit on the mundane side, but say suppose, for example, you want to get your passport or something. So right now this involves interactions with multiple departments in the government. And this is all kind of done in a very, very proprietary way. It's hard to do. But with interoperability with clouds, this might become extremely easy. Today, as this other cartoon over here shows, there is no interoperability, and to make something interoperable takes a lot of effort. Yes.
So is it like an application developer, or is it for storage, or is it for whom interoperability is required?
So that's a very good question. So let me just give a more detailed answer a little bit later. So in short, my answer is that we have to find out who is asking for interoperability and do that first. And so interoperability is not like, okay, I had a vision, I'm going to do it. That's not the way the internet evolved. Internet, people said, okay, I want to do this. For example, internet when first, this probably shows you my age. When I was doing my master's, if you wanted to send an email to say Berkeley, you had to give the full path. You'd have to say something like exclamation point, India gateway, exclamation point, US gateway, exclamation point, California, exclamation point, UCB, something. That would be the way path name you had to give. Then somebody said, why do we have to do this? Let's just do automatic routing. Let's have this DNS concept which will do automatic routing. So we cannot come up with a vision, but we have to see what is important. So I'll just go over that in a minute. Excellent question. Thank you. So if you take a look at, again, why this is important for India, government departments, the government has decided to go up heavily for clouds, and they have empaneled 11 CSVs, cloud service providers. Okay, and it is pretty clear that since there are 11 CSPs, and we want, I just gave the example earlier of digital locker, which is store your documents digitally. So each department will have its own digital locker. Like for example, income tax department may have a copy of your documents in their digital locker, and property tax may have their own digital documents in their digital locker. How will these digital lockers be able to interoperate? Okay, that is the question. So it will be also make it difficult. I just talked about the passport thing. If all of these are in different clouds, then how would these be able to interoperate with each other? How will you build these applications which are cross-cloud applications and then enable the next generation of cloud computing? Okay, so that is a question. I think interoperability is definitely crucial to cloud in the rest of the world, but given the ambition and scope with which you are trying to do Digital India, is probably very crucial to India. So a little bit of what we are trying to do in the standards in standards interoperability in CCICI. And so we have two activities. One is a task force. The task force, the goal of the task force is to foster technology in activities to our standards in interoperability. So what we are trying to do is we are trying to first of all work with various standard bodies, including SNIA, to try and develop standards where those standards do not exist. The second thing we are trying to do, and that's what we'll demo a little bit, is we are trying to develop the software which will allow clouds to interoperate with each other. So these are the two things that we are trying to do. And so we have a team of developers who are working on this and so on. Again, So we want to have an engagement here both from academia, because academia is a trusted, neutral thing for doing this kind of thing, and of course industry to bring the industry perspective, and government because it's a strategic partner and also a big major consumer of cloud services. So this is one activity, the interoperability task force, which is developing interoperability software. The other activity we want to launch is an interoperability test bed. So suppose, for example, somebody comes. As I'll show later, we are going to talk about interoperability with OpenStack. So suppose somebody says, okay, we have OpenStack interfaces from VMware, from IBM, from a lot of different vendors, including OpenStack itself. Now, if these are all claimed to be, these may all be claimed to be interoperable. How can we test that they really are interoperable? So this brings up the question of what is interoperable, and we would say that if you can federate the clouds to make a hybrid cloud, then that is interoperable. Then that is interoperability, because our ultimate aim is to be able to seamlessly federate different clouds together and make it look like one seamless cloud. So if I can do that, the clouds are interoperable. So now, in order to make the clouds interoperable with each other, I'll be having some software which uses some APIs in the different clouds. To give you an example, OpenStack has something called Keystone Federation, by which two OpenStack clouds can be federated. If I have got one version of OpenStack and let's say another version of OpenStack or OpenStack from a different vendor, and these are claimed to be interoperable, then they should be able to federate with each other's Keystone Federation. The Keystone Federation is accomplished by doing steps A, B, C, D, E. So I can write a test suite which will test it and say, okay, can this really be federated? Can these two clouds really federate with each other? And that is what we want to do in the interoperability test bed. We want to have a test bed which is hosted at 3 different centers which are vendor neutral. And we want to develop a test suite so that, say, we will have OpenStack running on one of these centers. And if somebody claims they are interoperable, we can have installed that cloud there. And we can run a test suite which will say that is it really interoperable. And if it's not interoperable, we can point out what are the APIs that fail. And so when that is rectified, the clouds will become interoperable, and we'll be able to federate them and make them as a complete hybrid cloud, seamless integration with hybrid cloud. So in the interest of time, I'll just skip over this. Basically, there are a lot of standards. So our approach has not been to come up with yet another standard which will supersede all of these standards. What our approach is, there are a lot of standards, and in order to federate the clouds, which is a complete set of standards we need. For example, we need security standards, we need many storage standards, and so on and so forth. So our idea is not to invent a new standard, but to decide which standards, when combined together, will give total interoperability for the cloud. Okay. And now I come to this gentleman's question, that what do I mean by interoperability? At what level, the application level, etc., etc. So there is an organization called the Cloud Customer Council in the United States, and they have studied this question of interoperability, and they have come out with a number of use cases as to what are the most important use cases for interoperability. So our approach for interoperability is going to be that we will do this in phases, and let's say each phase takes 6 months. So at the beginning of the 6 months, we will see what are the use cases that are important today. What is it that customers want? When they say interoperability, what is the important thing that customers want? So we will implement those. Then after that, when we are done with that, we'll see what's important in the next 6 months. So we are going in this manner because, as I said, we cannot predict how the cloud would evolve, and we cannot predict what is going to be important at any given point of time. So we will be driven by what is important. So at any point of time, we will be talking about what is important in that point of time, and we will be doing that. So here are 6 use cases which the Cloud Customer Council, which is there in the United States, they have identified these as being 6 important use cases where hybrid cloud or interoperable clouds would be important. So the first use case is guaranteed performance against abrupt load increase. So what happens is that I have service provider 1, and the load on service provider 1 is very high. Okay? So I would like to shift some of that load to some other cloud provider. Okay, so that essentially means that so right now I can do things like auto scaling. I can find out when the load on these systems is very high, and when the load is overloaded, I can. So what I need is I need to be able to burst the VM from here to here. Okay, that's what I need to be able to do. So this is one of the use cases we'll be showing. And then when the load goes down, then these VMs should die, and in most cases, and it should come back to here. So this is one use case which the Cloud Customer Council in the USA has deemed to be important. Uh, Another use case would be guaranteed performance at a remote location. So this is important for mobile users. So I have, let's say, a health provider or something, I think. They have, they're taking a business trip abroad, and they want to locate their data they're normally accessing the data here, they want to access it there. So then we'd like to have the data pre-copied into a location close by, cloud location close by, so that the data access time is less. Then use case 3 is guaranteed availability in time in event of disaster. So what that means is we will periodically snapshot data from one cloud to another cloud, so that in case of a disaster scenario, I will be able to do this. So again, many of these things can be done by proprietary means today, but our idea is to build this into the cloud, so they become sort of standard services which everybody can use, and not this one. The fourth use case is enhanced convenience by service cooperation. I already talked about this a little bit, whereby if we have, say, a passport kind of a thing, then we want to be able to, if this requires talking to different departments like the police and so on and so forth, we would like to be able to allow this to happen automatically and not through some hardwired thing. Then we have service continuity, in which case we can have an application running on multiple clouds, and they will continuously be in sync with each other, so that if one goes down, then the other would be there. So right now this can happen within a cloud, but it cannot happen across clouds, and that is what we would like. And this service continuity case could be an important use case if what we are trying to do is we are trying to migrate from one cloud provider to another. Let's say we were not happy with the current cloud provider, we want to go to another cloud provider. This could be a useful case in that. And finally, a kind of very high level, more futuristic thing, whereby I have an account in multiple cloud providers, and when I want to deploy an application, there will be a market broker, and the market broker will take a look at which cloud is the best cloud for me at this point in time. So for example, some of you may be aware that Amazon offers what is called the spot pricing, whereby when their demand is low, they will give virtual machines at a discount, but those virtual machines can be killed at a moment's notice. They're not guaranteed to survive. So there may be some applications which I'm running, and I'm periodically checkpointing, so I don't mind if the application is terminated suddenly. So in that case, I could check Amazon to see if they're having spot pricing which is cheaper than the current VM I'm doing, and run that particular application on Amazon, for example. So of course, this is another very, so these 6 cases are the cases which the Cloud Customer Council has identified as being important use cases. And as we progress more and do these, more and more will become interesting. So let me talk about the architecture which we have over here. We are focusing on OpenStack federation. The reason for that is OpenStack, so standards of 2 kinds. There are the de jure standards, which means some standard body goes ahead and declares this to be a standard. But there are other standards, like for example, in the cloud storage, there's the Amazon S3 API, which has become a de facto standard. And de facto being that those things have been used, is so popular that for all intents and purposes, even though it was not invented by a standards body, it is a standard. And OpenStack that way seems to be on the way to becoming a standard, because as you can see, practically every vendor offers an OpenStack interface to their cloud. Okay, VMware, in the case of VMware, it is, and IBM, it is a native thing. In some of the other cases, a third-party thing. But anyway, an OpenStack standard is, API is available as a standard to everybody in all clouds. So what we are thinking is that if we federate OpenStack clouds together, then in that case, we can effectively federate also a lot of other clouds. In OpenStack itself, there's a lot of interest in federating OpenStack clouds together at this point. And if we can federate OpenStack clouds together, that may help catalyze hybrid clouds and so on. So that is the area which we are taking a look at. And these are just some of the, these are just, a very, very high level architecture. At the top, you have the application that runs on the federated security, which is Keystone. Yes, thanks. And then there is the federated storage, federated network. These are modules we built using OpenStack APIs. And Heat is the auto scaling engine, which will scale things up and down and so forth, the federated Heat. So I would now move on to the demo, and in the interest of time, maybe let me just quickly go through what CCICI is doing. So if you would like to volunteer, we'd welcome you to come and volunteer. So here are some of our accomplishments in 2015. We've been actively involved in DEITI with the cloud computing strategy. We've worked with the government of Telangana to help them establish their data center. We have formal MOUs with IEEE, CS, of course, with SNIA, and CEG Karnataka. We've had, we played a very active consultative, to summarize, we've actively played an active consultancy role with many of the government things in helping formulate cloud strategy. Yeah, so you can participate as a collaborator working on a working group like ours with developing interoperable software, or just join as a subject expert. Okay, so the demo. I'll turn it over to Shreyas.
Thank you.
I think you have 10 minutes.
Yeah.
Oh, sorry. You have a mic? Okay,
Yeah.
sorry.
Right now, I am going to show you the demo, how we have obtained interoperable between two OpenStack cloud providers. Okay. We have two cloud providers. Left tab indicates cloud service provider 1 and right tab indicates cloud service provider 2. And these both cloud service provider are based on OpenStack. And now let me create an instance, and it will be created in the cloud service provider 2. Now, one of the things you have noticed is that the availability zone, which we have built our own framework, which gives, if we choose the availability zone, it would communicate with the cloud service provider 2, and all this cloud service provider 2 are have single IDP server, centralized IDP server, where we can exchange the tokens and all those things. Nova, you are asking here in the video. Yeah, this is local to this. This Nova availability zone is in service provider 1. it's like pseudo availability zone. Okay, means there is availability zone, but when it hits the availability zone, the compute node, it will actually go and create in the service provider too. You could see we have the image of cloud service provider too, and it has been prefixed by the IP address of the cloud service provider too. Now here listing, we have enabled listing. Whenever the listing of instance occurs, we'll automatically fetch the instances in the cloud service provider 2 and display it in the cloud service provider 2. It's like block storage for select the availability zone. And now in this case, we have one use case known as attaching volume to remote instance. Attaching remote volume to remote instance, cloud service provider. That is the I'm doing. Provided of the cloud service provider too, and when it executes, it should create in the service provider. Across the clouds. One, if the load increases in one cloud service provider, then we will scale out to different service provider. We'll create an instance in local service provider and we'll monitor it and we'll increase the load, and it needs to scale out in the service provider too. And the details of those availability zone flavor and image have been provided over here. That instance details have been provided over here. completed, and 3 instances has been scaled out. Now let's decrease the load in service provider 1, and let's see the scale down process.